we now have a question that has to do with gravitational potential. And what the question contains is very simple. Calculate the gravitational potential at a point on the Earth's surface. Suppose the Earth mass is given as 5.98 times 10 raised to the power 24 kg. Its radius as 6.38 times 10 raised to the power 6 meters. And then the general gravitational constant as 6.67 times 10 raised to the power minus 11 Newton meter squared kilogram squared per kilogram squared. That's what we have here. What do? We first of all write down solution, okay, and then bring out the content of the question. That's the first thing. The data contained in the question is very, very important. Let's see. The mass of the Earth, or Earth mass, is giving us 5.ME. M is giving us 5.98 times 10 raised to the power 24 kg. That's the first thing. Second thing we need to do, we consider the radius. The radius, the mass of the Earth, and then this, before we now state the formula. So radius of the Earth is given as 6.38 times 10 raised to the power 6 meters. We record the gravitational constant G as G, universal constant, is given as 6.67 times 10 raised to the power minus 11 Newton meter squared per kilogram squared. Whichever way. You can write it in this form or in this form. No problems. So let's look at it. Having identified the parameters contained in the question, the next thing to do is to write down the formula that will be used to solve the question. And the formula here, we already learned in my previous video that to calculate gravitational potential, we need to use V is equal to minus G M, this time around ME, and then RE. We are talking about the radius of the Earth and the mass of the Earth, respectively. That is it. So if we understand this, the next thing to do is substitute accordingly. We substitute. V is equal to what we have as G, we do that, and what we have as E, we substitute. So let's go. We substitute at this point. V is given as, for G is 6.67 times 10 raised to the power minus 11, bracket close. That's for the gravitational universal constant, or universal gravitational constant, so to say. That's for G. Then the next is ME, the mass of the Earth. The mass of the Earth is given as 5.98 times 10 raised to the power 24, bracket close, all over. Radius, distance separating the point where the work is being done from infinity in bringing a unit mass to that point where the gravitational field should be felt. That is the radius. Now let's look at it, and it's given as what? 6.38 times 10 raised to the power 6 meters, all closed. And look at it very well. Alright? I have done a lot of work here. And if you have watched up to this moment, come on, give me some thumbs up, my friends. Give me some hard thumbs up, big ones. Subscribe, come on, hit the subscription button and belong to this family. Push on the bell button for constant notification. And then remember to share with your friends, network, and students. You know what? You are going to supply the answer here, and that will show you are going to supply the answer here. Yes. Check it. Just look at it. Supply the answer and give me the units. Give me the units. Supply the answer here, and then give me the units. I want to use this to know if you actually watched it to the end. If you watch it to the end, thank you for your patience, and thank you for watching to the end. Then prove to me you like something that has to do with science. punch a calculator, okay? Simplify this with the answer. Let's learn together because learning is continuous. Thank you so much for being part of this family. See you in my next class. I signed out to prepare that next class. All right, today.